All right, welcome back to another episode of Modern Cyber. We've got another guest joining us from the other side of the world today, and I always find that it's a lot of fun to talk to people from other parts of the globe because they might have different perspectives, different experiences from what a lot of our audience experiences in North America. My guest today is Dan Draper. Dan is the CEO and founder of CipherStash, a data security startup building a searchable, encrypted data storage platform for sensitive data. We're going to get into what that actually means in some level of detail in today's conversation. We'll see how we go. Dan previously worked as a VP of engineering at MedicalDirector and at Expert360. He's an experienced cryptography engineer, and his mission is to empower all the developers with the knowledge they need to build secure applications, something that is super important in the modern technology landscape. Dan, thank you so much for taking the time to join us on Modern Cyber today.
Hey, Jeremy, you're welcome. Great to be here.
Awesome. Well, let's start a little bit with your journey and what you guys are up to at CipherStash. When I hear, a searchable encrypted data storage platform for sensitive data, there's a lot in that phrase right there. So talk to us about some of the key components and some of the key problems that you're helping customers solve.
Yeah, absolutely. So you're right. There's a lot of technology in CipherStash, but every piece of technology that we've created has been very intentional, very connected to the underlying problem. And so in some sense, I like to think beyond the technology. What is the actual problem we're trying to solve?
Right.
You think about every data protection company on the planet right now really has one thing in common. Okay. That one thing is that everybody's trying to limit access to data, make sure that it's controlled and it's locked down.
Yeah.
CipherStash actually takes the opposite approach. We want to make data accessible. And it's this concept we call trusted data access. So without access to data, if people that work in an organization who need access to particular records or particular information, if they can't get access to that data, then the data is effectively useless. So how do organizations capitalize on the data that they capture, but in a safe way? And so that's really what CipherStash is trying to solve. It's sort of like the Goldilocks of access control. It's not too little, it's not too much. We want to make sure that we give folks access to the right amount of data at the right time, and that such access is always recorded, it's auditable, and in some sense provable to the extent that such a thing can be done.
Okay. I mean, that makes a ton of sense. And I guess it's not quite what you were saying, like every data access company is trying to limit access to data. I would say what you're trying to do is make sure that only the people who have access to the data can access the data, right? And similarly to that, I think one of the things we look at, for instance, at Firetail with regards to APIs is, do you have access to the data for the action that you're trying to take? So a lot of times on APIs, I give the example of something like a social media profile where I can access my profile, I can access your profile. I can edit my profile, but I can't edit your profile, right? So the action that I'm trying to take with the data also factors into that, right?
Absolutely. And I love that. And I think you guys are really, blazing a trail, pun intended, I suppose, as well. And it's why we've connected and become friends, is we have similar kind of mindsets. I think traditionally though, if an organization or a product had to fall on one side or the other, if you're going to have a more restrictive approach versus a more allowing approach, it's always the more restrictive approach that folks end up taking, and that ends up causing all kinds of problems in teams and productivity and all that sort of stuff. So, and there's no perfect solution, but that trusted data access piece where you focus on allowing the access, but in a trusted way, that's really our spirit.
Yeah. You said something else there that I think is a little bit almost maybe a little bit of a controversial take, but I do kind of agree with your sentiment there, which is if you think about kind of, the buzzword of zero trust, most approaches that I've seen towards zero trust, and remember, I'll remind people and this is like a common saying, zero trust is a philosophy, not a piece of technology. You cannot buy zero trust. It's like a strategy for how you think about structuring access to systems, data, process, people, technology, platforms, etc. Most zero trust approaches that I've seen, they kind of start with a denial, and then we give explicit access to people based on certain conditions, whether that's role-based access or attribute-based access, or let's say application-based access or what have you. And like, I've always thought about this approach as like, it makes a lot of sense on paper, but I think something that you said kind of hints at what's going on is that like, we're accumulating data at such velocity that it's very, very hard to keep track of who should have access to what, right?
Right. Yes, 100%. It gets very complicated very fast. And in my experience, what tends to happen is, you're right, it starts with a denial type approach, although that in itself is actually more difficult than it seems in a lot of contexts. And we'll talk about that perhaps in a moment. Okay. But the person or the team that is making that decision about who's allowed access to what data, there's a huge responsibility on them to make sure that they get those decisions, they make the right decisions. But also they have to have a really good sense of what might happen in the future at a given point in time. So if I'm a data security engineer and I'm defining some policies, I want this group or this person to be able to have access to a record. What happens when the conditions that led me to that decision are no longer true?
Right.
Then things change, right? So whatever system you have in place has to be adaptable. And so one of the kind of philosophies that we've lent into very heavily at CipherStash is start with deny all, but access is very much a just-in-time thing. So you are only making the access decision at the point in time when the user needs or is making a request to access the data, where we're using standard technologies to drive some fundamentals, and then using some more, I guess, novel technologies to do the last mile, if you want to think of it like that.
Okay. And so that's where some of your, let's say, like your key technology comes in, really, is at that last mile.
Right. Okay. Yeah. So think about, I guess I'll give you a kind of concrete example, or two concrete examples, actually. So one is there are some really obvious ways in which you might want to think about applying the denial pattern. And so one is, and this is sort of where CipherStash started, is the difference between access to infrastructure versus the access to data within that infrastructure. And I'll talk about that concretely. Hopefully that makes more sense. So you have a database. Developers or engineers in your team need access to that database in order to run migrations or backups or schema changes, what have you. But they don't necessarily need access to some of the underlying data within that database, the actual records or fields in the table.
Right.
And so one really simple way to mitigate that is encrypting the values in that table, also the sensitive values. As contrast to something like row-level security, where an administrator in a database could potentially modify the row-level security rules, and so then you're reliant on trusting that the administration team within the organization is doing the right thing. Where the encryption in this context plays a really important role is when customers themselves can control the key or the key derivation process. So in other words, a vendor that is capturing sensitive data on behalf of its customers can store encrypted data in its table, in the database table, and only the customer can decide whether or not that data is allowed to be accessed. Okay. And that really flips the model quite a lot compared to traditional technologies.
Yeah.
The other interesting example, I can see the cogs turn.
Yeah, it's excited. I already have at least one follow-up question that I want to ask. Actually, you know what? Let me ask it now before we get into your second example, because otherwise I might forget it. All of that makes total sense. But in real time, in the real world, how do you pull a human into that loop fast enough for it to be meaningful, right? Because I think like one of these things around data access requests that I've seen in organization after organization over the years is that like, okay, we realize, to your point, somebody's changed roles or they've now got a new customer assignment or whatever the case may be, but they now have a change in their data access status, right? So they should or should not be allowed to access data based on some change. And like what I see time and again is that people get behind on these changes, right? Because somebody has to go and make this change. So, Dan has to go in and change the group policy object or adjust the permissions or add an attribute to Jeremy's user profile or whatever the case may be. And like these things back up. And so what ends up happening inevitably over time is that we overcorrect towards Jeremy's just a member of this team now, access to all data that this team has access to, right? Like we fall into that kind of, I don't want to call it a trap because that's not right, but we fall into this like trade-off situation again and again and again. So like, how do you make those decisions quickly enough is really what it comes down to.
So the context here is very, very important. And actually, I think this does connect nicely with the other example that I was going to mention. So let me talk about the other example, and then maybe we can try and join the dots. So the second example is we have a customer. They are a health tech organization. Okay. They have doctors and patients, and this is in Europe, in Norway. Doctors are saving patient records for the patients that they see. Now, rather than a traditional policy might be, so let's say the doctor is Dr. Smith, you might have a policy that says only Dr. Smith is only allowed to see these patient records. Because of the context, we can actually do something simpler, but also more effective. And so that is that you can say, using encryption technology, only the person who wrote the record is the person who's allowed to read the record. And with traditional row-level security, that's actually quite difficult to do, certainly in a robust way. With encryption, certainly with our encryption technology, what we can do is connect that with your identity provider. We can know who you are and take the proof of your identity embedded into the encryption. And then only when you can prove that you are the same person again, can you retrieve those records. So then the context of the data access is the thing that determines how the policy is applied. And so you end up with, I guess, policy principles rather than concrete policies. Another example is when you've got let's say you're a vendor. One example we use sometimes is you're a calendar optimization vendor. There are a lot of them around at the moment.
Yep.
We want to connect to your corporate calendar, say G Suite, pull in all your calendar events. Now, the problem is, as soon as you sign up to an application that does that, a vendor that does that, they're going to connect to your Google Calendar. They're going to suck in all of your calendar events, say the last 12 months. And then you might decide after a week of using the product that you don't like the product anymore. You don't want to use it. Now the challenge is that vendor still has 12 months of data in your system. It's up to the vendor to decide, did we delete this data? Do we have an access rule in our system that means that no one in our team can see it anymore? Like what happens to it after that? And so in this context, what you want is a system that as soon as I, as the end user, decide to revoke my authentication, so I disconnect it from my G Suite OAuth, I should no longer be able to access the data in the system, and nor should the vendor. So by the context, the relationship between me and the vendor has changed. So therefore, the policies that are inferred by that relationship are changed. So in some sense, what we're talking about here is highly context-dependent policies that can be inferred or defined based on the nature of the relationship or the scenario, rather than having to rely on a security person determining what low-level policies might make sense depending on their best judgment.
Yeah. Do you consider this parallel or the same as kind of ABAC, attribute-based access control?
In a sense, it's a form of attribute-based access control. In some sense, what we've done is extended the concept of ABAC in both directions. So one, we can capture a broader range of attributes that can be proven. So your claims from your identity and so forth. So it's expanding the number of attributes that you can use in a policy, and extending the enforcement layer. So the enforcement now becomes part of the encryption, and so you end up with a much more flexible and wider reaching system. In a sense, it is an ABAC, yes.
Okay. And I guess, if I think about kind of everything that we talked about relative to this problem, right, that we're trying to solve, there's an underlying thought that sticks with me, which is that, this has been a problem since I started doing IT. Right back in 1997, to date myself, kind of who has access to what files, what data, whether it's files, data, rows in a database, tables, whatever. Like, this problem has been around forever. What's changed about this problem over time?
Yeah, so I think you're right. It's something that I've struggled with my whole career as well. Once again, I think the context is important. In my experience, doing these kinds of things in databases is probably the most challenging, and that's consistently where the bulk of our data ends up. When I say databases, I mean warehouses and lakes and those kinds of things.
Yeah, sure.
And I think a couple of things have changed. So one, the encryption technology has been around for a while. Now, you don't have to use encryption technology to solve this problem, but I do think encryption is a very powerful way to do it, because encryption allows you to do two things. One, it becomes a deny by default policy mechanism, whereas if you think about storing data in, say, a Postgres database, and then in a Snowflake, and then in a MongoDB, and then in some vector database, traditionally what you'd have to do is define policies and rules for each one of those different databases. Then very often, certainly in the case of a relational database to a warehouse, you want to synchronize data from your relational database into your warehouse. There's some ETL process. So what permissions and policies do you have around the ETL process? Does that become a potential attack vector or weak point into your security chain? So what encryption allows you to do is encrypt the value once, and then have that the access to that data be denied by default no matter where it goes. So you end up with sort of a universal policy, universal access control. Only through the application of the appropriate decryption algorithm can you access it. Now, that's very powerful, and historically, the last decade, you could use something like Amazon's KMS to do that, or an HSM. Right. That sort of thing's possible. The reason, in my view, that hasn't been taken up really a great deal is because if you apply that kind of encryption technique to existing databases, your database technology doesn't work properly anymore. And what I mean by that is you want to query, say, somebody by their email address, you want to sort them by their first name. None of those things work anymore. And so one of the enabling technologies that has started to become, move out of academia and into industry over the last decade is this idea of searchable encryption. So you can take a query, an SQL query, say, encrypt that, send it to the database, run queries over encrypted values, get an encrypted result, and then only when the authorized user tries to access that encrypted result can they actually access the values. So I think searchable encryption is an important one. Yeah.
And this is as a result of something like a one-way hash, where like the kind of the unidirectional hash always kind of resolves to the same encrypted value. So you don't have to search for, Jeremy at firetail.io. You search for the hash that's generated through the one unidirectional, kind of encryption of that value, right?
Exactly, yeah. So one-way hash is a good analogy for it. And some of the different searchable encryption schemes use one-way hashes as part of the construction, but they're actually much more sophisticated than that. And so as an example, you can do range queries. There's a form of encryption called order revealing encryption, where you can say, is this value more than, less than, or equal to some query. That allows you to do sorting as well.
Yeah.
We can at CipherStash, we've also developed a scheme to do fuzzy text matches. So we effectively can replace the like keyword in SQL and do that over encrypted data. Now, some of your audience may be familiar with a technology called homomorphic encryption. So homomorphic encryption has been around for a few years as well.
Yeah, I've heard this phrase, and I've never actually had the chance to kind of do a deep dive onto what that actually means. So maybe give us like a 1-minute primer or something, if 1 minute is possible.
Yeah, sure. I'll have a crack. Homomorphic encryption is, I guess, like the superset of searchable encryption, in that you can take two values that are encrypted using this scheme, this homomorphic encryption scheme, and apply any operation to them you like. You might add them together, you might multiply them, you might compare them. It becomes a general purpose, I guess, mathematical function that you can apply to encrypted values. So you take two encrypted values in, you run some function, you get some encrypted value out, and then when you decrypt that value, that is the same as if you had applied the operation over the unencrypted values. So hopefully that all makes sense. It's gained a lot of interest over the last decade because it is very compelling. The problem and the major limitation with homomorphic encryption is it is incredibly slow. To put that in perspective, if you were to use it, say, to query a database and say you wanted to use the comparison function on a homomorphic value.
Yeah.
So just really simply to do a sequential scan in a database, that might, over a few million records, might take days to run.
Right.
So these operations can take like a quarter of a second per operation.
Yeah.
Searchable encryption, on the other hand, is incredibly fast. So there's hardly any overhead compared to doing it on unencrypted values. And so the schemes we're using, for example, even the slowest scheme is still literally 100,000 times faster than homomorphic, can operate over data in a few milliseconds.
Yeah.
So that's the major piece that's exciting there.
Gotcha. That makes a lot more sense to me now than it did, 3 minutes ago. So I appreciate that primer on that. It kind of brings me to the next question, and I want to go a little bit deeper on this kind of question of encryption. Encryption is something to me that I think, like a lot of people, I just look at it, it's like, hey, does the website have the little lock icon on it? Are we using SSL? And like, oh yeah, there's this TLS thing and blah, 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 right? But like, generally speaking, other than, encrypted files on my hard drive and whatnot, I kind of take it as a given. And I kind of take it as like a, turn it on for the places that I know I need it. Whether that is, again, like my hard drive, or whether that is, again, an SSL certificate or on an API gateway in front of an API, or whatever it is that my use case is. But I know that there are different algorithms behind all of these different encryption techniques. And one of the things that we've all heard a lot about over the last couple of years is, oh my gosh, quantum computing is going to break encryption. So I guess like my perspective on it is, I hear about this. I don't know necessarily if it's hype or truth, or nobody really knows what the current state of it is. For you, as somebody who spent a lot of time looking at encryption, like, what's your take on it? What is real for what is coming around quantum computing, and how it will or won't impact the state of current encryption?
Yeah, such an interesting question. So I'll start with the bottom line up front, is that I am not the slightest bit worried about quantum computers breaking encryption.
Okay.
And let me clarify why. So there's a lot of hype around quantum computers and this potential threat of being able to break encryption. And there's a couple of different ways to think about it. So let's imagine for a moment that a quantum computer, a stable enough, powerful enough quantum computer, was available tomorrow. What might happen? In the sense that you have, right now we're using what you might call encryption in transit to communicate over this link via our podcast studio. That is using a form of public key encryption. And in fact, if you were to go on, open the developer tools in Chrome or something, it would probably tell you what kind of encryption it's using. And more than likely, it's using something called elliptic curve cryptography. If you happen to have an old browser, it might be using RSA. I hope that it's not, but RSA is a commonly used public key encryption technology as well. Now, these are the encryption schemes that are theoretically vulnerable to a quantum computer, and that's because of a guy called Peter Shor, who in the 90s, long before any practical quantum computers were in existence, he developed this algorithm, a theoretical algorithm called Shor's algorithm, that can break the public key encryption scheme using of RSA or elliptic curve in a fraction of the time. Technically speaking, it's a much more efficient algorithm, and so the theoretical runtime is much smaller. It still does take time, but it's something that can run, within a few hours or maybe days, rather than if you were to try and break elliptic curve encryption with a classical computer would take billions of years. So suddenly the public key encryption becomes vulnerable. What people don't talk about enough is, I'm going to give you a couple of things to think about. So one is that the public key encryption that is used is only for the exchange of the key. So right now, what is actually doing the encryption is the symmetric cipher. So a scheme, typically it's AES, so the advanced encryption standard, or you might have something more exotic like a char poly or something like that, but it doesn't really matter. None of these symmetric schemes are vulnerable to the algorithm that Peter Shor proposed in the 90s. And so then what we need to think about, if these symmetric schemes are not really of concern, how do we improve the security of the public key encryption schemes? And so there's quite a lot of work being done right now on what's called a post-quantum secure encryption scheme. So NIST, the National Institute of Science and Technology in the US, ratified new post-quantum secure encryption schemes. There's a number of them now. Probably the most famous one is Kyber, called Kyber, or now increasingly being referred to as ML-Chem. It's a key encapsulation mechanism. These schemes, and in fact, if you're using Cloudflare or a number of modern kind of content delivery or website delivery platforms, more than likely you already are using quantum safe encryption. Like if you're in Chrome and you go and click inspect and you look at the certificate and the encryption mechanism, it's most likely it's going to be using post-quantum encryption already. And so then that's assuming that a quantum computer already exists and is stable enough. We've kind of already covered our backsides. So then the next interesting question is, well, okay, how far away is a quantum computer that could actually do this? And no, I'm not a quantum computer expert, but you start to speak to the experts and you pull back the curtain from a lot of the media hype and so forth, and you start to realize that we're still a very, very long way away. And to give you an example, Shor's algorithm that I mentioned a moment ago is a factorization algorithm. So it's designed to very quickly factorize or determine the two numbers that multiply together to result in a asymmetric key. There's a bit of math and sort of technical nuance there, but effectively what the algorithm is doing is working out what those factors are incredibly fast. The largest number that any team anywhere on the world has ever used a quantum computer to factorize is in the 20s. So I'm talking like 23 or something. Whereas we're talking about with RSA or with elliptic curve, RSA, for example, is a 4096-bit number. So that's a very, very long number. And most quantum computer experts that you speak to will say, in order for us to factor that kind of number, we're at least a decade away. So while we're getting all these interesting advances, and I am excited about quantum computer technology, by the time we get a quantum computer that's even possible at factorizing those numbers, everybody's going to be using post-quantum cryptography. And not to mention that the other technology that you mentioned is the idea of disk encryption or database encryption. Yeah. These they're always using symmetric encryption, which are not vulnerable to this Shor's algorithm.
Gotcha. And if I say to you, thank you for that, by the way, that was an extremely helpful way of thinking about it. But if I say to you, just to kind of like test my understanding and also test some of what you said, okay, everybody except for the people who are still stuck on mainframes. Right. Like, is that a concern, or is it, no, even those systems are going to be, let's say, like transmitting over lines in network infrastructure that where the encryption is going to be done at a different layer and this becomes irrelevant?
Yeah. So the problem is not in the sort of the ephemeral key that is being generated. So right now, as I mentioned, we're talking about this encryption in transit link. There is an encryption key that's being used to encrypt our traffic. But as soon as we end the call, that encryption key will be discarded. And the next time we get on a call, it'll be a different key. So long as the technology continues to update, then any new keys that are generated will be safe. Of course, the point you make about mainframes and legacy technology is indeed a concern. And I think we are going to have a problem in the next decade or so, where, not dissimilar to the Y2K problem for those that are old enough to remember what that was about, where we had to update our systems. We're probably going to end up with a similar situation, right?
Where we've got this kind of like, in 3 months, IBM or whoever is going to release the new quantum computer that is going to be widely commercially available, or at least commercially available, maybe via one of the cloud provider platforms or who knows where, at a price point where it is actually feasible for somebody, threat actor, nation state, whoever, to use it for whatever purposes they might.
Right. Exactly. Yeah. So there is a process that we have to adopt as an industry now over the next decade or so to start to migrate to these post-quantum safe encryption schemes.
Yep.
But the reason that I'm not concerned, although like I get it, Y2K was not straightforward, but the reason Y2K ended up not being a problem was because everybody updated their systems. It's non-trivial to go and update their systems, and we have to do the work.
Yeah.
But the reason I'm not concerned is because this threat of quantum computers is not imminent. It's not something that's like right around the corner. It's not something that we have to go and solve for tomorrow. And this concept that people talk about the kind of the data collection problem, where you have some nation state collecting a bunch of data to store for later use. That is still potentially a concern, and we need to be conscious of that. Nonetheless, there's still some time. We have time to go and solve these problems. So I think my number one advice to folks that are listening, if you are thinking about this quantum problem, probably the most impactful thing you can do with any legacy systems is try to understand what your migration to post-quantum safe encryption systems looks like. If you're considering a modern encryption scheme, something like CipherStash or any of the number of players on the market now, make sure that they're using quantum safe technologies. And I would suggest that by and large, we all are now. So certainly for new technology, it's not a concern.
I just pulled, out of curiosity while we were talking, I just pulled up the certificate signature algorithm, not for Riverside that we're using to record, but actually for Google Docs that I've got here in another browser window. And I've got PKCS #1 SHA-256 with RSA. And so I assume that PKCS is already kind of post-quantum or what stands for something along those lines.
No, in that case, PKCS is, I forget what the algorithm is, but that's referring to the certificate type, I think. We're going to do a bit of live
Googling, captivating content.
Yeah, so that's just standing for public key cryptography standards, right? So the key word that you've mentioned there is RSA. So you're using RSA, that's interesting. It's a shame that Google Docs is using that. But I'm just curious now for your listeners, if we're using it on Riverside. I might not be able to do it while everybody's listening. We'll come back to that perhaps. But I'm reasonably certain, like CipherStash.com, for example, Linear, the dev management tool, GitHub, a lot of the companies that we use day to day are now using the post-quantum encryption standards.
Got it. Yeah.
So we'll start to see more and more of that over time.
X9.62 ECDSA signature with SHA-384.
Yeah, so the DSA in that context is the digital signature algorithm. So that is using the traditional either RSA or that would be RSA essentially using it for digital signatures. So that is not quantum safe. So we haven't had a good hit rate yet.
No.
But
we're
for those listening, I'd encourage you to have a look at the websites that you're browsing and see what they're using. The one thing I would mention is that you do have to have a really up-to-date browser to capitalize on that. So the older browsers don't support those new schemes yet.
Yeah. It's funny. The browser has become so important in this whole, really in like the whole of the modern workspace. I think it really is one of these kind of overlooked but super critical points. And we've got some stuff we're doing on that side around AI that we'll be announcing in the next little while. But I want to shift gears for a second as we kind of, come towards the end of today's episode, because there was something that you said kind of in our pre-record that really resonated with me, and which is like, we talk about, let's say, like the different parts of the problem that we are trying to solve today, whether it's encryption, whether it's data access that we talked about at the beginning of the conversation. And you said something to me, which is like, part of the discovery and the lessons learned of your own journey in cybersecurity, and as you've built out CipherStash, is that sometimes it's hard to get non-security people to care about security. So share with us a little bit about kind of like what kind of led you to have that position, and how do you think about getting people to change their mindset around it?
Yeah, I have another slightly controversial take, actually, Jeremy. My theory or my hypothesis is that unless you are a security engineer or a security person who work in cyber, you probably actually don't care about security. What you care about is something that security enables for you.
Right.
And most business people, and I am a business person, you are a business person as well as a cyber person, so we have a foot in each camp. But what we actually care about is growing our business. We care about building trust with our customers, closing deals, generating more sales, all those kinds of things, right? And it's an interesting realization that we've had at CipherStash. How do you convince somebody that security is important when actually deep down, even though they probably will never admit it, they don't really care about security?
Yeah.
And most security, and once again, the present company accepted, but most security vendors will try and sell on fear.
Yeah.
So this fear of data breach or fear of lost business or being held ransom or whatever, right? And those are genuine concerns. And you probably, if you're not afraid of what's going on in the world right now, maybe you should be a little bit.
Yeah.
But fear is not. I think in our industry, people get sick of the fear angle. It is a powerful motivator, but when you're getting bombarded all the time, you should be afraid. You kind of get desensitized to it.
Yeah.
And so what we've started to think about is, well, what are the positive ways that you can sell security? What about if you didn't have to spend so much time worrying about if you were going to get breached, and now just focus on closing deals and generating more business and building trust with your customers? And so at CipherStash, we think a lot more about this idea of our motto is kind of protect data, close deals.
Yeah.
So if you are a vendor, SaaS vendor or an infrastructure provider, and you can convince your customer that using your product is a more secure, safer option, and you don't have to go through all of the anywhere near as much of the procurement pain as you had to in the past, is that compelling to you? Turns out the answer is yes.
Yeah, it's funny. I personally had a very specific moment when I actually realized that cybersecurity is important. And mine was just a random set of circumstances that kind of led to a little bit of an epiphany moment, honestly, in my own career trajectory. I'd been in cybersecurity. I'd done it hands-on keyboard practitioner for the first half of my career, about 13 years. And it was one of those things that like you always had to do. But, at that time, I will say this is kind of the 1997 through like 2010-ish timeframe that I was still kind of involved in the day-to-day operations of both our IT systems and our cybersecurity systems. And even at that time, what was really interesting about it was my own perspective on it was IT is the thing that enables the organization because they need tools and they need systems that they can use to build on top of, right? Every marketing guy needs a laptop. Every salesperson needs a mobile phone. Whatever the thing that they need in order to do their job is, that's what it is. And what's happened over, let's say, like the 10-year time period from 2010 until 2020 was that the number of threats really went up from my perspective. And also, by the way, the number of risks, like self-inflicted risks, right? Like the kinds of accidental data exposures because we all moved to the cloud in the mid-2010s and we didn't understand that we shouldn't leave S3 buckets open to the world and stuff like that, right? Like, so we had this kind of proliferation of data, proliferation of new systems and new technologies and new threat actors and, criminal gangs and ransomware as a service and the dark web and all the things that are real things, right? That are real threats to organizations and to their data out there in the world. And even I, with all of that exposure and all that experience, and by the way, like from 2016 to 2020, I worked at a cloud security posture management company where we grew very rapidly and we helped a lot of customers around the world. And even in 2020, at the end of that journey, I was like, man, security is rough. I just don't think my heart's in it. I just don't think like I'm doing anything super meaningful. And then we had COVID. And during COVID, I know so many healthcare organizations were just under constant attack. And I talked to a couple of organizations that were instrumental in kind of helping all of humanity out in getting out of the pandemic. And I can't say more about, exactly what those customers were and what they did, but let's just say that like we're all here today in large part thanks to them and the work that they did. And I kind of realized something was that like, the work that I had done in the previous 4 or 5 years up to that point actually helped them move forward. It actually helped them like to embrace cloud systems where they could do new things and they could build with a sense of security, knowing that their intellectual property wasn't going to be hacked or stolen or whatnot on a regular basis. And so like all of these amazing minds who came together and worked on some very, very important and difficult problems, I realized, okay, I was not going to be one of those people. That's not my mindset. That's not like my core competencies as a human to go be that person. But I do understand how these security systems work. And I do understand like to your point, the role that this can be as an enabling function to allow an organization to move forward. And in my case, it was a little bit less on the, let's say, the deal focus around what you just expressed. But I do take that point, by the way. I do think like any small company who's going and trying to sell to a large company, one of the first questions you're going to ask if you hold the customer data is, show me your certifications, show me your security standards, show me your whatever, right? So like I truly empathize with that. I think it's a great way to frame the question. I've had a similar kind of gripe on my own, and a little bit of a hot take is that I think only security companies care about secure by design. When I talk to organizations about what they're doing for their security strategy, I hear a lot of kind of defensive stuff around production environments. When I talk to security companies, I'll hear that, but then I'll also hear about what they're doing to eliminate vulnerabilities during the build side, what they're doing for secure code reviews, what they're doing for all types of things around, like, sometimes down to the basics of like, how do you control request parameters on an API? Like, do you have good input sanitization and validation? Like some of these core basic functions that similarly you would think are part of a programming best practice for the last 20 plus years. And yet we still see like day after day after day that they just get overlooked in favor of move quick and break things.
Right.
And so like, I think we share similar perspectives on this, but I really like your take on like it actually enables more sales. And that's an important thing.
Yeah. And more sales is, is our particular flavor of that, that characterization of it. But to think of it more broadly, I think it's just simply about confidence. And I know we're running out of time, but to wrap up, the way that I think of it, the analogy that I have, if you have to cross, a chasm, you need to get across the Grand Canyon. You could walk across a tightrope. You're a highly skilled tightrope walker. You've got your big long pole, and if you know what you're doing, there's a reasonable chance that you'll get across safely. But let's be honest, most people are not going to do that because that's very high risk. If that is what the world looks like when you don't have good security in place. In contrast, if you have a bridge with nice high guardrails, it's made by engineers, it's built with steel and concrete, everybody's going to feel perfectly safe going across that bridge. And so people now have confidence to operate and do the thing that they need to do because they trust that the security is doing its job. They don't care about the security per se. They care about their goal, but they just need to know that they can have the confidence to go and do that thing because the systems underlying what they need to do are working properly and they're secure.
Yeah. I think that's a great analogy, and I think that's a great note to end today's episode on. Dan, if people want to learn more about you, your work, what you're doing, what's the best place for them to check out?
Yeah, take a look at CipherStash.com, learn about our business and our technology. We have a number of open source technologies that people may be interested in as well on our GitHub, which is linked from the website. And of course, if you'd like to connect with me on LinkedIn, Dan Draper, just look me up and I'd be happy to connect, and always happy to chat.
Awesome. We'll have both of them linked for the show notes. Dan, thank you so much for taking the time to join us on Modern Cyber today.
Thanks, Jeremy. It's been fun.
Awesome. We will talk to you next time on another episode of Modern Cyber. Remember, if you know somebody who should come on the show, please have them reach out. And if you know somebody who wants to come on and talk about their breach story and what they learned from it, we've still got a few slots on our breach series, season 1, We'll talk to you next time. Bye-bye.